Hello friends. So today we'll discuss about data structures. The next data structure is a stack. Already we have studied array. In the array itself, we were talking about arrays can be used for implementation of different data structures. One of the data structure which can be easily implementable using array is a stack. So stack is a linear kind of data structure. It is stored sequentially as if array is stored. A data structure where insertion and deletion of the items takes place at one end, and that particular end is called as top of the stack. So as if we execute the stack using array has two ends. It starts with the index 0 and ends with the index n minus 1. We can insert a data in either end of the array. But in a stack, we have to define one end for inserting and deleting or removing the item from that particular end. The other end will remain closed always. So, stack is also referred as an abstract data type because stack has two main operations. One is push operation and the other one is a pop operation. These operations are independent of what kind of data type you use. If you use character, integer, float, image, etc., the operation and the behavior of the stack will remain similar in any condition. That is why we call this stack as a abstract data type. This is an example of a stack. So look at this. This is considered as an array. We have 1, 2, 3, 4, 5. 5 different spaces, blank spaces available for storing a data. These blank spaces are known as memory spaces, where we can insert a data or remove a data. As we said, only one end is used for inserting a data into this particular stack and taken out of this particular stack from the similar end. So this end is open for inserting a data as well as taking a data out. The other end is closed and we are not able to use this particular end for insertion or deletion, so it remains closed. So the two operations that we use are push as well as pop operation. These two operations will help us for execution of behavior of the stack. As we keep a data in to the stack, the first data will be stored here, and this will be always pointed by stack top. It is known as stack top. So stack top will always point to the data which is inserted or which is latest inserted data in the stack. So we keep the data in and we keep the data out. So as the behavior of the stack, we can refer this as a last in first out operation. The data which is last in will be first time taken out of this particular stack. This is a small example of a stack. This is an empty stack. So we do not have anything in this stack, but we have lot many blank spaces, memory spaces available here. So we do not have anything inserted here. So we call this particular stack as an empty stack. Now we push a item 2 or a value 2 into the stack. So once the 2 is inserted in the stack, at top of a stack, will point to this. Then we do a next operation known as push data item 5 in this stack. Once we inserted 5 data item in this stack, it will be inserted after 2, and this will be pointed by top of the stack. So this top pointer will always keep pointing to the start of or to the last entered item. Next we enter is 7. The operation is push, the data item is 7. Once we insert the data item here 7, then top will start pointing to the last data entered in this tag. Then the next operation is push 1. One data is inserted in this tag and top will start pointing to this. Similarly, it keeps going until unless the stack size will be full. Here, the reverse operation, taking a data out, is known as top pop operation. The first operation, pop, is executed. It will take the item which is pointed by top out of the stack. See here, we have 1 is pointed by top of the stack. So when we execute a pop operation, it will provide us the 1, the latest data value which is top of the stack will be taken out. Once the 1 is taken out of the stack, then top will start pointing to the 7. Then we again will try to execute a push operation here. So push 21. Push 21 is inserted in the stack and it will be inserted after 7, and top will keep pointing to 21. When we execute pop operation, the pop operation will take 21 because 21 will be pointed by top out of the stack. Then we will execute another pop operation which takes 7 out of the stack, and then again the next pop operation will take 5 out of the stack. So this is how the push and pop operation will be executed on stack. Then what are the applications of stack? Now we understood how does stack executes or it works. Stack is used for many different applications. Some of them are implementation of functions, parsers. Parser is a process used in compilers and a linker loader kind of programs. Expression evaluation. The expression, whatever you have provided, is right or wrong, will be verified with the stack. Stack is one of the functionality needed for expression evaluation. Then backtracking algorithms, if we want to execute, we definitely need to use a stack. Next is a stack is its example like a dinner plates. If we keep one on one, then that can be considered as a stack of dinner plates. Then one of a real-time example that you can refer is the potato chips kept in a Pringle box is also known as a stack of chips. We also have a particular definition for this is last in first out, or you can say that first in last out operation of a stack. The basic operation principle is that last item that you put in is the first item you can take out. This is how we refer it as a last in first out or first in last out operation. Next is a stack application. As we said, that stack is usable for execution of a function. In the previous slide, we were talking about applications of stack, and the first application is execution of a functions. We know that we can write multiple functions in C programming or C++, Java, etc. So it doesn't matter which programming language you use, but stack is used everywhere. Wherever you have functions, you will have to use a stack. Let's assume that this function named as function 1 has a function call of a function 2, whereas the definition of function is written here named as function 2. This function 2 again have a function call of a function 3. The definition of function 3 is written here, and then a particular statement or a function in this particular function is written as console.trace in the bracket called stack. So this is how a program is written. The program says that function 1 calls a function 2, function 2 calls a function 3. So this is how a switching between a function will work out. How does it work using a stack? Whenever you execute a function 1, then stack is not being used. But when you switch from function 1 with a function call to function 2, then the current details of a function 1 has to be stored, so that once we execute a function 2, we have to get back to the previous environment and execute the remaining statements in the function 1. Again, when we switch from function 2 to function 3, we have to store the current details of a function 2 properly, so that when we come back from a function 3 to function 2, we have to finish the remaining part of function 2. How does it work? When we execute a function 1 and we make a call to function 2, the current details of function 1 will be stored in a stack. This says 1. The details of function 1 are stored here. Then we go to function 2 and make a function call, say 3. When we make a function call 3, we have to switch here. But before we switch, we will store all the details of function 2 into the stack. After 1, then 2. And we go to function 3. Once we execute all the details in a function 3, then this particular function is called, say, console.trace. So before that, we have to store a details of function 3 here. Once we finish the details of function 3, then it has been removed. Then we'll move back to function 2 by taking the contents of function 2 as an environment and finish the details remaining in a function 2. Once we finish all the details of function 2, then it has been taken out of the stack. Then the next remaining thing is function 1. We will go back to function 1, execute all the details and remove function 1 from a stack. And this is how again the stack will be empty, so that the complete function execution is completed and this is done. The stack is also used in microprocessors. This may not be a part of your syllabus, but we are supposed to understand what are the applications of stack. Stack is referred in the memory. So we have this as a memory in the microprocessor. This diagram belongs to microprocessor 8086. It has memory details known as a stack segment. This is a stack segment, or known as a stack memory, whereas the contents in this memory are always pointed by SP, known as a stack pointer. So we have a stack pointer which is always pointing to the contents of stack segment memory, and which helps us for execution of stack by microprocessor. Every microprocessor has a stack and stack related operations, so that the function related operations will be done very easily. So as we know, or as we understood how the stack will behave, according to that, a program has been written here which explains the actual behavior of a stack. So these are the header files. Then we have defined a maximum stack size is 5. Then in the main, the 3 different variables are defined, say item, choice and I. Then an array for stack is defined. The maximum size of this array is 5. It's already defined. So one more variable known as top. It's a behavior for pointing top of the stack. Initially it is defined as a 0. It shows that it is an empty stack. Then we have exit1, a variable defined to exit of that particular stack. The statement printf will define simple stack example array. We have a do while operation. While is exit. Here we are using an exit variable to exit out of this particular loop. Someone can use one directly here. Then printf stack menu is prepared. That is, 1 is for push, 2 is for pop, 3 is for display, and other is to exit. Enter your choice. The choice is a variable we have considered here. It is an integer data type and it will get a value from a user either to push into the stack or for a particular cases. Switch case. So case 1, 2, 3 or other will be pressed by a user. A compiler will expect a value known as a choice from a user. Then once the value is collected in, if it is a push operation, then it will go to top of the stack and maximum size. If it reaches to the maximum size, that is 5, so it will say that stack is full. It means all 5 values have been pushed into the stack and there is no remaining vacant space is available for a new coming data, then the stack is known as a full. If stack is not full, means data is not available in a stack, then we can take the value from a user and push it into the stack. So the data will be collected in the item to be stored into the stack. Once we get the data into the item, then we store this item into the array known as array stack and a top value will be incremented. What was the top value? Top value was 0 and now the top value is 1. So ARR stack is now 1 and data value item is inserted to this top. If we can make a break. So this is how, again, if a user wants to enter another value, the value will be collected in item and that will be inserted here by incrementing top to 2. So the new value entered will be pointed by top always because we are incrementing the top 1 before we insert a value to that particular location. If we want to take the data item out of the stack, then we have to use the operation known as pop, which is the second choice in this particular switch function. So the 2 is defined. So top is, if a top is equal to 0, it means no data values are available on a stack. So the stack will be defined as empty. If stack is not empty, means some items are available in the stack, then what we do, we will decrement the top, and once we decrement, we will take a data value of a current location out and display it to user, which the display is for which particular atom has been taken out of the stack will be very easily defined here. And third, we will have to say that display the current contents of a stack. For that, for loop is used and we can see all the position and the respective values in the stack. This is always visible whenever user press the 3, the values will be available to the user. Then if anything else will be pressed by user, it's a exit and we will come out of this particular program. This is how we can execute a stack using a array. I want you to execute the same program, or you can have your own idea for execution of stack using array. If you have any question, you can write it to me. I will try to explain all the answers in the next lecture. Thank you.